Hey there viewers, I want to record a quick video on how to find the RPMs on a fuel pump. So I have a Syscomp circuit gear oscilloscope. I got the current clamp in channel A. I got my clamp turned on, 1 millivolt for every 10 milliamps, or every 1 millivolt equals 10 milliamps. So we're going to go ahead and zero it out so we know it's zeroed. And let's go ahead and hook this guy up. Now I have the ECMB fuse pulled out, and this is right next to the fuel pump relay, this gray relay right here. Now keep in mind that this fuse doesn't just power the fuel pump, so if you want to do a current reading on the fuel pump, how much current that fuel pump is drawing, it's not going to be just drawing, you're not going to be just reading the fuel pump current, so you're also going to be reading other stuff that's on this circuit, so just bear that in mind. So I got it zeroed. We're going to go ahead and hook this baby up, and if we come back over here, and let me get the camera in close, I think you guys can see that. If we look here, channel A, I have set on 1 volt. So for every horizontal dashed line equals 1 volt. So there's 1, 2, 3, 4, 5. So in this section right here, we have 5 volts. So 5 volt amplitude. If we look at the sampling, it says 5 milliseconds. I hope you can see that. For every vertical dashed line equals 5 milliseconds, and there's 10. There's 5 here and 5 here, so there's 10 across the screen. So across the entire screen equals 50 milliseconds. That's 50 milliseconds across the entire screen. Now, once you have a waveform, now we're going to go ahead and, if we come down here, I'm going to do single shot reset. So I'm going to reset that so our waveform that we had on there disappeared. And now I'm going to hit this manual trigger right here. Okay, there's our single shot of a 50 millisecond waveform. And now to record this, and you go up here to tools, you have to actually have the waveform on there. And then you just hit the export waveform, and it's going to export it into a CSV. That's a file that you open in some sort of a spreadsheet like Excel. So in the background I have Excel opened, and if we look here, we have a low spot here and a low spot here. Fuel pumps typically range anywhere between 8 to 12 commutator segments, and if we count the spikes, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 spikes. So this fuel pump has 10 commutator segments. Let me get off of that right there. So let's check our time real quick. If we look at our low spots, let's go. It looks like from here to here. So let's move this guy over to about, I would say about there. And let's grab this other one. And let's move him right here. And I hope you guys can see that. Let me bring the camera in a little closer. So we have 8.89 milliseconds. Now we're going to get a calculator out and we're going to figure the RPMs. But I put it on the low spots where it looks like it's repeating on that pattern. So let's go ahead and shut this truck off. I'm going to turn my clamp off. We don't need to keep the truck running. And let me look here, let me grab the calculator. Let's figure this real quick. Now, so the way you figure the RPMs, you're going to take 60,000, so 60, and I hope that's on camera, times 10 to the positive 3, so 60 times 10 to the third power. And we're going to take our 8.89 milliseconds, which is one cycle, That's one cycle or one period, one rotation of that fuel pump. So every rotation is about 8.89 milliseconds, give or take. And so we're going to divide by 8.89. Now you're not going to put times 10 to the negative 3 in here. So you're not going to calculate it with the milliseconds. And that's because that's already figured up into the 60,000. So you take 60,000 divided by whatever the millisecond time is, but you don't put milliseconds in. And so that equals about 6,700 RPMs. And let me bring it in on the camera. Trying to angle it. Hopefully you guys can see that. So it's difficult to record with this oscilloscope. I would not recommend getting this oscilloscope, but just based on the fact that it's hard to record a waveform. There's other oscilloscopes out there like picoscopes that are really good. But anyway, again guys, this is just figuring the RPMs on a fuel pump. And this is a Chevy S10 4.3 liter. And the fuel pump is a Delphi fuel pump. So I hope you guys find this video useful. Thanks for watching.